Hello and welcome all. I, Professor Ashish Apate, Department of Engineering Sciences at AISSMS IIT Pune. Today we will see ellipse by concentric circle method. In conic sections, ellipse, parabola and hyperbola are called as a conic section. First of all, what is meant by cone? A shape or object that has a round base and a point at the top is called as a cone. If I cut the cone in different or some typical cutting planes, then I'm getting a shape like ellipse, parabola and hyperbola. So first of all, this is cone, this is the base. Axis of the cone, these two lines are end generator of cone. This is section plane and I can say cutting plane. Now if I cut the cone from the section plane or cutting plane, then shape appears on the cone is ellipse. So I'm repeating again. This is a cone, axis of the cone. These are the end generator of the cone. This is section plane where we are cut the cone, and if I cut the cone from this to the section plane, then the shape appears on the surface of cone is ellipse. Now suppose second figure, this is cone, then axis same axis and the end generator of the cone. This is the section plane. Now in second case, see this cutting plane, I am changing the cutting plane position, and this cutting plane is parallel to the end generator. This cutting plane is parallel to the end generator, and if I cut the object from here, this cutting plane or through the section plane, then the shape appears or curve appears on the surface of a cone is called as a parabola. I'm repeating again. This is cone and this section plane, this section or cutting plane is parallel to this end generator. If I cut the cone from here, then shape of the shape of the surface appears on the curve appears on the cone or is called as a parabola. Then third, this is third figure. Now see that I change the position of cutting plane or section plane. If I cut the cone from here, and the curves appears on the surface of the cone is hyperbola. Okay, this is the difference between the ellipse, how we can get the ellipse, then parabola and the hyperbola. So we are changing every time the section plane or cutting plane, position of this cutting plane. First of all here, then second, it cut the both the end generator and also intersect the axis of cone. In parabola, it is parallel to one of the end generator and it cut axis and the end generator. In third, it cut only one end generator and it is parallel to the axis of cone. So this is the basic difference between ellipse, parabola and hyperbola. Now, in engineering curve, they included ellipse, parabola and hyperbola. So method for important method for first year is in ellipse, concentric circle method first, then second one is a rectangle method, and third one is a basic locus method, or we can say directrix focus method. Same in parabola, first one is a rectangle method and the second one is a basic locus method or directrix focus method as per the syllabus of STP. In hyperbola, important method is rectangle method, or we can second one is a basic locus method or directed focus method. So these are important methods as per the SPPU syllabus. Next, these are the common definitions of ellipse, parabola, and hyperbola. So generally we define the ellipse, parabola, and hyperbola on the basis of eccentricity. The first of all, what is meant by eccentricity? Eccentricity is the ratio. Means that these are the loci of points moving in a plane such that the ratio of distance from fixed point and a fixed line always remains constant. The ratio is called as eccentricity. If the E or eccentricity, E stands for eccentricity. For ellipse, E is less than 1. For parabola, E is equal to 1. And the hyperbola, E is greater than 1. So these are the difference. Now second definition of the ellipse, that is that it is a locus of a point moving in a plane such that the sum of its distance from two fixed points always remain constant. These two fixed points, that is focus 1 F1 and focus 2 F2. This is a major axis, minor axis. So vertex, this co-vertex, and this sum equal to length of major axis. So if I these 2 points, sum of this distance from two fixed points, that is one is here and second one is here. If I add this distance and this distance, this is equal to major axis. And these two fixed points are focus 1, that is F1, and F2. Okay, we'll see one problem on concentric circle method. So first of all, I read the problem. Draw ellipse by concentric circle method. Take major axis 100 mm and minor axis 70 mm long. So they are clearly mentioned here, measure length of major axis and minor axis. Now, first of all, step 2, draw ellipse by concentric circle method. So first of all, I know the major axis distance, that is 100 mm. So this is my major axis. Suppose this is 100, I mark it 100 mm, and this is minor axis 70. Always we mark the major axis on x-axis and the minor axis on y-axis. This is the intersection point. It is exactly 50 from here and 50 from here. This is 35 because height of the minor axis is 70. So height or length of the major axis is 100. So it is intersection point is 50 from this end, left or right. Then next point, these are the intersection point. So the intersection point, take intersection point as a center and draw two concentric circle, considering both as a respective diameters. So definitely these are diameters. That is, this is 35 mm above from the intersection point and 35 mm below from the intersection point. The first of all, see, mark their point, that is A, B, C, and D. Then draw the circle, this as my center point, and take this radius and draw a one circle. This is one circle completed, inner circle, and then second one, again this is my center, take this as a radius O to intersection point and draw a outer circle. The next, extend these two lines up to outer circle. And then next, I have to divide this circle into 12 equal parts. It is not necessary to divide this circle into 12 equal parts. We can divide it into 8 equal parts, but it's easy to draw the ellipse if I divide it into 12 equal parts. So we can simply divide the angle. So divide into 12 equal. Then next part is numbering. That is 1, 2, 3, 4, 5, 6. I'm not repeating here, already B is there. So 6, 7. I'm shifting this 6 here. 7, 8, 9, 10, and this is my 12. A is my 12. So inner side 1, 2, 3, 4, 5, 6 here. Not repeating here. 7, 8, 9, and 10 and 12. So the next part is to numbering. Then from all points of outer circle, draw vertical downward line. This is the word, or vertical, or we can say outer circle. From outer circle, draw vertical downward line from this, not necessary, it's already vertical line from 4 point, 5, 10, 9, 7 and 6. Okay. So next part is from all inner circle. We have to draw horizontal line. This line intersect the vertical line. Those vertical lines means from all points of inner circle, draw horizontal line to intersect those vertical lines. From point first, draw here, it intersect here. This is my first point. Then second, I have to draw, and this line is exactly horizontal line. This line is parallel to this one. Okay. So second, I got a second point. This intersection point, vertical and horizontal line, is my required point. I'm getting a second point. The third is here. Then fourth, then fifth, sixth, 7 point. Then 8, not necessary to draw. 9, 10, and 12. So then next part is to mark the points. This is very important point. Always mark the all point and give numbering. That is P1, P2 something, or C1, C2, whatever you want. 4, 5, 6, 7, 8, 9, 10, 11 and 12. The next part. Try to join a minimum 3 to 4 point by using the engineering French curve. Don't draw 1 to 2, 2 to 3, 3 to 4. Don't draw this curve. Draw maximum or join maximum 3 to 4 point of a 3 to 4 point of a curve. And next, minimum 4 point, 3 to 4 point. Then next, and this is your required ellipse by concentric circle method. I am repeating the step again. First, we have to draw. They are given here 100 mm major axis and 70 mm minor axis. So, first of all, draw major axis 100 mm and minor axis 70 mm. Then intersection point definitely 50 from this side, 50 from this side, 35 from above and below. It's my intersection point. Then this is my center. Take this center 35 as a radius of this center to C. That is A, B and C. D are the names of these endpoints. Then center to C is my radius. Draw a circle. This circle is inner circle. Then second, this is my center point. A to center is my radius. Draw outer circle. Then next, divide this circle, inner and outer circle, into 12 equal parts. So I know that this is 360 degrees. So divide into 12 equal parts. Then whatever we divide by 360 divided by 12, we can get the angle, mark your angle and divide into 12 equal parts. Suppose 1, 2, 3, that is 30, 30, 30, 90. So from here 30 mark here, then 30, I'm getting 1 point, then second, then third, then fourth, fifth. So divide this circle, these two circles into 12 equal parts and numbering them. That is 1, 2, 3, 4, 5 up to 12. I'm shifting this 6 here because already this point is B and this is A. So I'm not repeating as 12 or 11 or is 6. Okay, and same for the inner circle, that is 1, 2, 3, 4 up to the 12. Okay, Then next is draw from all points of outer circle, draw vertical line downwards and upwards respectively. From these points, I have to draw downwards, and it is approximately draw. That is not by scale. Just vertical. This line is parallel to this one, minor axis. Okay. Then third point is here, not necessary to draw. Then from point 4 feet, then 6 vertically. Now here from vertically upward. From 6, from 7, 8 is not necessary. Already is here on the vertical line. Then 9 and 10 and already is here. Then draw from all inner circle. From all points of inner circle, draw horizontal lines to intersect those vertical lines which are already drawn. First intersection point here, I am getting P1 point, then P2, P3, then this one. Draw from 4 points which intersect the previously drawn line, 4 line. This P4, P5. Not necessarily draw here because it is already drawn vertical line. Then from 6, from 7, 8 is not necessary. 9, 10 and this. And the last or most important part is we have to join minimum 3 to 4 points by using engineering French curve. So this is try to match is 1, 2, 3 or 4 points by using engineering French curve and draw complete the curve one by one. That is 3 points or 4 points. Then next this 3, 4, 5 and this 6. Then this B 6, 7 and 8. Then 8, 9, 10 and 8. And this is the required ellipse by concentric circle method. Thank you all for watching this video.